In this video, I come against the following definitions regarding finite and infinite sets. These are: 1. A finite set is a set whose smallest and greatest elements are known. I have issues with that. And 2. An infinite set is a set whose smallest or greatest element or elements is or are not known. I have issues with that also. These statements apply to some finite and infinite sets, but not to all of them, and so must not be used as definitions. Here is what I offer. A finite set is any set which has a finite number of elements, whereas an infinite set is any set which has an infinite number of elements. But if we don't want to use the words finite and infinite, we can say a finite set is any set which has a limited number of elements, while an infinite set is any set which has an unlimited number of elements. We can as well say a finite set is any set whose cardinality is less than infinity, whereas an infinite set is any set whose cardinality is infinity. Let us note that infinity is not definite. There are many infinities. Consider the set A and B defined as follows. A is the set of all x such that x is a natural number, where x is greater than or equal to 1, but less than or equal to 5. B is the set of all x such that x is a real number, where x is greater than or equal to 1, but less than or equal to 2. In both sets, we know the smallest and the greatest elements. A has 5 elements, and so it is finite. B has infinitely many elements, and so it is not finite. There are infinitely many real numbers from 1 to 2, just as there are infinitely many points between any 2 points on a line. This makes the choice of a line as a representation of the set of real numbers very apt. We can list more elements of the set B if we take a constant difference of 0.1. We'll have 1.1, 1.2, 1.3, up to 1.9. We find 9 more elements in addition to the smallest and the greatest elements. This gives us 11 elements so far. Now, between 1 and 1.1, using a constant difference of 0.01, we can list the elements 1.01, 1.02, 1.03, in that manner till we get to 1.09. This gives us 9 more elements, but we have 10 of such intervals in the previous list, and so 9 times 10 equals 90. Thus, we have found 90 more members of the set. If we add this to the 11 we had, we will now have 101 elements. This, of course, does not make B infinite. It is not what makes B infinite. A set with 101 elements is still a finite set. Next, between 1 and 1.01, we can list more members of the set. We can do the same thing between 1.01 and 1.02. We can do the same between 1.02 and 1.03 and so forth. We can always do this. The fact that we can always do this is what makes the set B an infinite set. Remember again, between any two real numbers, not only is there a real number, there are infinitely many real numbers. It may seem counterintuitive to us that there are infinitely many points between any 2 points on a line. But this is only because we do not understand the mathematical conception of a point. My name is Delalina Gago. I represent Thinking Mathematics, a brand which is committed to raising mathematical consciousness.